All right. Thank you for everyone attending this morning or afternoon, I guess, depending on where you're at. My name is Jacob Pachinka. I am one of the research scientists at Rodale Institute's California Organic Center. And this morning slash afternoon, I'll be talking about one of the projects our team has been working on, which is finding edible options for cover crops in these California organic vegetable systems, which can be a little bit unique compared to a lot of places. And I like to start out these talks giving a little context of where we are in the state of California. Before moving out to California, I grew up in South Dakota and had lived in the Midwest my whole life. And so it's a totally different world out here in California, and agriculture is no different. So the California Organic Center is based in Ventura County, which you can see circled down there. And I really like this map that the Farm Bureau of the county puts out. It just shows you kind of a map of agriculture. So that yellow star towards the middle is where the organic center is, and anything that's colored is ag land. And as you look towards the top of the map and more to the center, those yellows, oranges, and greens are all avocados and lemons and citrus. So there's a lot of tree fruit as you go a little bit inland. But as you go towards the coast, those blues and reds, red being strawberries, a lot of strawberries in our county, and the blues being that kind of rough designation as row crop. So that's oftentimes any vegetable you can imagine, and depending on the time of year, whatever that vegetable is differently. So we're in this very diverse vegetable and specialty crop growing region, and because there are a lot of these fresh products that are produced, there's a lot of unique challenges and unique aspects of agriculture out here. One of them being how farms are looking. And this is data from the last time they did a census in agriculture, with this 2022. So within the county, there's a little north of 1,800 farms or farming operations. And what is really interesting is 74% of them are managing less than 49 acres, and 41% are managing less than 10 acres. So a relative majority of these farms or these farming groups or farmers are managing relatively a pretty small area compared to what we think, or what I grew up thinking of as the size of a farm in a lot of other parts of the country. A majority of these are family-run operations, but and within the county, as far as number of farms go, 7% are organic. So it's, again, not a majority by any means, and those of us at Rodale who work out here are striving to increase that acreage as part of our goal and mission in the county. But there is some amount of organic production, and what is really uh, different compared to a lot is there's no rest, or there's no break in the ag production cycle. As you could see in that map I showed, we're very coastal, so we're a true Mediterranean climate, and this is a map that is showing when peak harvests are. You can see on this chart, so as you move from left to right, it's through a calendar year, and anytime you see a colored bar, that's when those different commodities are harvested. And this is just a handful of them, but what I use it to illustrate is there's no winter time period where nothing is being harvested. There's uh, because we're close enough to the coast, it's a mild enough climate where there's always something to be harvested. There's always crops that are grown, even in December, January, February, where we think of, oh, this is winter. This is when things are shutting off. Uh, Growers can be growing things like celery, lettuces, other brassica crops, and they are in large quantities. And because there's production all year round, there's a lot of investment in these lands. A lot of these products that I'm showing here rely really heavily on uh, labor. So in a lot of cases, especially in organic systems where there's no herbicide or no sprays gone on, a lot of the weeding is mechanical, and a lot of the harvesting, there's no mechanized harvester or combine that you might think of in a lot of other cropping systems. There might be some implements that aid in the harvesting, but a lot of it is done through hand harvesting. And because of that, these ag products generate an incredible amount of value. And this is a fun example of that. And this is comparing in 2024 from the Pennsylvania, this is the entire state of Pennsylvania, their ag overview, the amount of money generated first by corn, $410 million across north of 650,000 acres, and soybeans being almost $260 million value across another 600,000 acres. But in just Ventura County, in that same year, strawberries generated $709 million across comparatively an incredibly small amount of land, just less than 11,000 acres. And this is, a little bit tongue in cheek, very much apples to oranges in a little bit of different ways because, again, strawberries are picked for quite a long time period and it's incredibly labor intensive. So the inputs as far as labor for fertilizer programs, for the you name it type of watering these products, the amount of inputs is also quite a bit higher. But it gives you an idea when a grower is thinking about what they're going to grow and making those choices or choosing what management practices to do if it comes at a cost to the production of their cash crop or vegetable crop. There's a lot on the line, and it makes growers, or it can make growers very hesitant or risk averse in a lot of cases. And I want to, I use we'll talk about the idea of a cover crop. And I know there might be some on the call and some with experience that know what a cover crop is, but I like to not just breeze by that 100 miles an hour. And so, really simply, it's anything that isn't your cash crop, isn't your vegetable or grain that you're harvesting in. What your cover crop is and what it's doing has a lot of flexibility. You can be improving the content and the fertility of your soil, suppressing weeds, reducing pests or diseases, or if it's something that just in between your cash crops, a way to have a living mulch or a way to keep the soil surface covered. And these can be anything. You can have a variety of grasses, oats or wheats, things that are in a lot of farming systems grown as a grain that's harvested, but instead you're growing these to produce a lot of biomass, to produce a lot of root material, or on the right hand side, legumes, your clovers, your peas, things that are forming associations with fungi in the soil to uh, take atmospheric nitrogen, nitrogen that's available, and turn it into forms of nitrogen that your plants can access and hopefully be a great source of fertility. And what you might guess based upon the title of this talk, there are also cover crops that, as you can see here, in a fava bean field with my two field assistants there, you can have cover crops that you can harvest or edible cover crops that you can use as a source of revenue. And anytime you're talking about cover crops, there's one big, whether it's a grass or a legume or whatever you're trying to do with it, you want to make sure it's not competing with your vegetable crop. And so termination in a lot of cases might be difficult. I want to, let's see if my video cooperates with me. Looks like it's not going to. I apologize for that. It was working for me earlier. But what that was showing is one of the implements that we have for these reduced tillage system, or the system we're trying to knock down a cover crop without doing a lot of tillage, and there'll be more pictures of it, is using something called a roller crimper, which is a large implement that flattens the cover crop. It doesn't disturb the soil or till it up. Instead, it lays it flat and has that cover crop material laying on the soil surface, covering the surface of the soil, protecting it, being that armor for the soil surface, while also, in an ideal world, doing a good job of suppressing weeds. And so what uh, we were trying to figure out is, can we evaluate a system, a sustainable system that's improving soil health, reducing weed pressure with these cover crop systems, and compare it to what I would call an organic standard or conventional organic practices that rely on a lot of tillage, so a lot of breaking up the soil surface and reusing, disturbing that soil and uh, that disturbance to bury weeds to keep the surface of the soil clear from anything that isn't going to be your vegetable crop that you're putting in. And so we wanted to do as good a job as we can quantifying benefits to weed suppression, looking at different ways we can terminate those cover crops to make sure that we're getting rid of them effectively. How are they doing suppressing weeds? And can we, before we're terminating these cover crops, get any sort of harvesting from them? And I want to kind of introduce this is very basically our experimental design. So this is the same kind of on the left-hand side is the beds all prepared that we had and flagged out ready for things to get seeded. And on the right-hand side is if you the nice color-coded view, and each of those sets of three rectangles are three of the beds. They're 40 inches across and 30 feet wide or 30 feet long each bed. And those color codes are how we are managing those cover crops. The brown or tannish color is the control, which is a bare soil treatment where it received no cover crop. We routinely tilled that soil to reduce the weed pressure, but there was no cover crop growing on it. All others had cover crops, but it was how we terminated the cover crops that differed. And I should say, this experiment went over several years, but the color-coded area, so the area that is green, that is listed as rototill, was the same space that was rototilled in every cover crop that we had throughout the duration of the experiment. And the rototill is an implement that has, compared to a lot of cases, relatively light tillage, but it's still taking that cover crop and chopping it up and burying it in the soil, where the uh, pink color is roller crimp. So that cover crop was grown and it was laid flat and smashed with the roller crimper. The oculation treatment, the blue, it was roller crimp, but then we placed a silage tarp over top of it. So this is not like the plastic mulch that you would see covering beds for weed suppression. Instead, this is a large, thicker tarp that's reusable. And for a several week period, you can use it to, one, help ensure that your cover crop stays terminated. So it's completely opaque. It's preventing light from reaching that cover crop that you knocked down. The idea that it would help it stay terminated, but we also have found that it can do a good job of facilitating early weed emergence. It's quite a bit warmer underneath that tarp. So weed seeds that are in there germinate, they try to come up, and they're unable to because just like the cover crop residue that's getting no light in it, flushes out and hopefully terminates an early stage of weed pressure. And the first cover crop that we chose was fava beans. So they were seeded in early February, and this is after a couple of weeks. We were worried at first because you can never really count on rainfall where we are in Southern California. We got a lot of rain. The fields, as you can see, were pretty muddy, but those fava beans really enjoyed that amount of rainfall, and we had amazing germination throughout the field. And what you can see here, early on, we did a little bit of cultivation between the bed and on the side just to keep those areas cleaned up early in the season to prevent any sort of weed competition. And as we, this next slide I have to talk about, this is just a nice, the first one is on a weed nearby the fava beans, but what, as we talk about cover crops in general, I wanted to highlight that there's a lot of benefits that you might see in making the choice to grow cover crops that and stuff that I see that I don't talk about, but there's all these additional benefits. And I am a entomologist by training, so that's looking at insects and pest management. And so I couldn't resist showing that on the far left-hand side, this is a cluster of eggs laid by a lady beetle. There is a lady beetle larva that's growing on, or that's cruising around on the leaf here. And on the far right, you can see one of our fava beans that has pretty substantial aphid problems. But if you look at, there is an entire army of lady beetles showing up. And so they're not just responding to this localized abundance of aphid pests, but by having the resources from the flowers that these fava beans grow or whatever your cover crop might be, it helps you retain a beneficial insect population. And so when you have your vegetable crop in a little bit down the road, if you see pest problems or if you see any sort of pest outbreak like aphid show up, it's really impressive how, if you're doing even a little bit to keep these beneficial insects around, how quickly they can respond. So a little bit of a digression, but I just couldn't resist showing you these beneficial insects at work. Back to the growth of our fava bean cover crop. This is, you can see that's myself posed with them to give you an idea of how sufficient they've grown. And we would routinely, compared to those, remember those bare soil beds that had no cover crop, look at the amount of weeds compared to them. So in our fava bean beds, it wasn't like they were weed free, and we took areas of the soil surface, collected weeds, weighed them, identified them, and there was some amount of weed biomass, but there was uh, over 8 times the weed biomass in those bare soil beds. So while these fava beans were growing, they were doing a nice job of suppressing the growth and ability of weeds to take over those areas. And later in May, as they were growing, you can see back to my field assistants here, we had help harvesting. So we would harvest subplots of those fava bean beds, weigh those beans, and we would extrapolate them out to, and we did 2 harvests. So we did a harvest from those first batch of big mature bean pods, waited a couple of weeks, and harvest them again. And with just those 2 harvests, you're seeing pretty substantial if you blow this up per acre. And speaking to some of the organic growers in the area who have had a success selling fresh fava beans, that this can be a pretty sizable revenue if you blow that up to a per acre basis. And I do want to talk about that. It averages out to about $50,000 per acre. But again, this is not something that, well, grow acres and acres of fava beans. You'll have no problem growing it. There's a lot of, and this will be maybe a common theme, but I want to make sure that I'm not saying that these cover crops should be totally supplementing income. But this is something that, as these cover crops are growing, these are legumes that are doing a lot to boost the fertility of the soil. But if you can spare the amount of these beans are growing, the labor to harvest, because as I mentioned, just you don't let the skilled labor force that I show here fool you. It can be quite a bit of time to battle through the growth and harvest them. And these $5 per pound and having the place to sell them is, as I kind of said, relies on you having a place to sell these. And so the growers who produce fava beans, they do it very in relatively small areas, and they have grown more and more because they find either sources of restaurants, or they have a customer base going to farmers markets or selling them fresh. If you were selling these to a wholesale or harvesting them as dry beans, there would be near that kind of value per acre. But for the grower is a little bit more entrepreneurial, they can also find different aspects. You can harvest the really tender tendrils of these fava beans as well as immature pods as additional sources of revenue. So it's really about finding, fava beans being the example we chose because we have experience speaking with growers in the region who have tried fava beans and found success and found ways to sell these. Because you can grow the best fava bean harvest you can, but if you don't have a good source to make your money back of the time growing them and selling them, it might be difficult to justify the time it would take, even though it's providing you these benefits to weed suppression and crop fertility. And this is termination. So I wanted to, what we did is we crimped the whole field, and then we went back and we would either till up the areas like the bare soil. You can see those are the slightly greener areas where for a period of time we couldn't get in there and till up the soil because we didn't want to crush our fava beans that were growing. But we had roller crimp, which you see here. Some of them were covered with a tarp, and then another chunk were with the rototill. And after a couple of weeks, this is right after that tarp was removed, that brown area, you can see what used to be those green fava bean stems. This is, in a perfect world, what it would look like. You've just uncovered it. There's not a lot of weeds, but what you can see in some of those other areas that are much greener, that is, in those couple weeks we had it uncovered, the weed growth that came back. So we did a little bit more weed management in between, and then it was time for our vegetable to go in, which in our case, we transplanted cantaloupes into those fields. So that's what you can see on the right-hand side. You can see those little couple leaves growing in there, but you can see what it looks like after a little bit of management, the different treatments there. And I should say the on the edges of the experiment, and you see 3 beds for one treatment, then a line of flowers or green material. That is just one, to give a little bit of buffer zone, and two, because we're trying to incorporate as many sustainable practices as we can. We always try to have every couple of rows a strip of a beneficial flower mix. So going back to what I said, having things that for a long period of time are flowering, creating floral resources for beneficial pollinators, for beneficial predator insects to hang out, and if we ever have issues with pest insects, they can come in and take the job. So this is just another view, and this is after a couple of weeks. So the transplants are still pretty small, but this is showing you the difference in what the weed pressure looks like. So on the far right, that occultation where it was covered with the tarp, early on it does a really nice job, but when it's just crimped and left open, even though you've got that mat on the soil surface, especially towards the edges of the bed where the residue of the cover crop might not be as dense, you do see weed pressure start to pick up, and that's something that uh, we're in most of the projects we have. It's continuing to find the way that we can best manage weeds, and some of the most problematic weeds are the binding weeds, or morning glories, creeping jennies. They have lots of common names with those. The plants themselves are pretty small, but they're very viney and can really ease quickly, as you can see here, take over an area and have a really smothering effect to the plant. But what we did see after a couple of weeks, we measured weed biomass, and that's what this graph is showing you. So each different colored bar is the average of those different little areas dedicated to either bare soil or being rototilled or roller crimpered. And what you can see is there is in that roller crimper treatment, and especially that roller crimper plus the tarp, there is a significant reduction in the weed biomass. And part of that is what we can associate with a significant amount of that cover crop residue being on the soil surface. So there was, even though a lot of it might be large stocky stems, uh, there's quite a bit of that fava bean residue that when we crimped it, that stays on the soil surface and has at least some effect on taking out the or reducing the amount of weed pressure. But even that picture that I have here, if you look towards the bottom, you can see the pink flowers there. That's the bindweed that is never far away from any ag experiment that we do out here. Uh, Towards the end of the summer, we would harvest the cantaloupes. I wish the harvest was better, but another battle that seems to be never ending in organic production is rodent activity. So for us out here, that's California ground squirrel is the biggest culprit. It's um, burrows in the ground, and so as you might imagine, it especially likes to take up residence where we're not doing a lot of tillage. So when the soil is left undisturbed, that's where they make their burrow, and if no one's mixing up the soil and messing with their homes, they really enjoy it. And despite trying to trap them and take care of it, it's they're very clever critters, and that's another priority for us is trying to figure out more and more organic practices because being an organic property and not wanting to use these really nasty chemicals, there's not a lot of effective uh, toxic baits that can be used in these systems. But we were able to get some yield data, and this is just showing per plant, so it's hard to extrapolate it out too much because of the limited amount of yield. But we do see that in some of these treatments, uh, especially the where they were crimped, and even that rototiller treatment, we saw a sizable boost uh, compared to the cantaloupe yield in those bare soil beds. So some promising results that I wish, again, we could. We'll have to continue to try to look at the rodent side of things. But after these cantaloupes were harvested uh, and mowed up that existing plant material, we seeded a fall cover crop, which is field peas. And these peas aren't the peas that we think of like sugar snaps that we harvest and eat. These are peas that are bred to produce a lot of biomass, which they you can see in some areas it was spottier than others. For whatever reason, we had in some chunks germination wasn't as good as we had hoped, but in some areas that we were able to harvest not the pea pods but the tendrils, the really tender curly vines that you're coming up. This is another way that just even though you're growing a cover crop that some of these small diversified growers in the region would grow these peas just for harvesting those tendrils, which are desirable as garnishes or sold fresh. But just like I said before, even though at a dollar per ounce, you think of well, that's not a lot of weight, and that can really add up. Again, it's you have to have crews out there individually picking and harvesting those tendrils. And because you're just clipping the edge, you have to sell them relatively quickly. You can't pick a huge amount and stick them in the fridge, even under cool conditions. They don't last quite as long, and you have to have relationships with either, like I said again, the customer base who want at farmers markets who are willing to buy this fresh product or a reliable source of local grocery stores or restaurants that again those are what small farmers in this area that have the large metropolitan areas of Santa Barbara and especially Los Angeles that they can sell these products to. All that to say, this is the termination of the peak cover crop, and this is does a really nice job of showing you that where those tarps are. So that's where they were crimped and then covered with the tarp for a period of weeks, and then closer you can see where it was either the bare soil that they were no cover crop was grown, or closest to us where it was grown, but then rototilled in, and so instead of staying on the soil surface, a lot of that material was buried. And because we have the luxury of growing crops during the winter, we transplanted and Napa cabbages in January of 2022. So this is the cabbage really small that you see on the left-hand side, and this is as they start to really take off and grow. Uh, as you can see, they're really vulnerable early on when that, but as they can start to put their elbows out and those early leaves can spread out, they can do a good job of creating space for themselves to make room for weeds. And this is showing similar to the other picture. It's with these cabbages. It's a little bit later, so it's a bit more difficult to see. But you can see some amount in, especially in the winter, uh, the weed pressure is there's a lot of grasses and these weed grasses that come up and can be the source of weed pressure throughout. And what was whether it was a combination of keeping those beds undisturbed from the cantaloupes to the peas without breaking up the soil and mixing up that weed bed, or just the ability of those cabbages to smother it a little bit, we saw really good weed suppression from, especially like I said, that roller crimper plus tarp treatment, where we were significantly less amount of weed biomass that, uh, as you can see here, might have contributed to really good cabbage yield across the board. Um, there's marginal differences between a few of them, but whether it was the environmental conditions, but we were really happy with the size uh, and the amount of cabbages that we were able to harvest. So this is the size of the cabbage per plant. So you can see among the treatments there wasn't a huge amount of difference, and if you took per area, so of the number of cabbages that successfully grew and the weight across all of them, there weren't very any statistical differences that we could see in this cabbage crop. And after we harvested those cabbages at the towards the end of April and into May, we did some bed work. So this is the beds cleaned up and ready for the next crop, which was lima beans. So this is a cover crop that is more frequently that needs a little bit warmer conditions. So even though you can grow things in January, February, there's some even cover crops that are more suited for being cool season versus warm season, and lima beans being one that needs a little bit warmer soil conditions. So had them seeded out here. In some cases that we had less than perfect amounts of germination, and in some cases they took a little bit longer to grow. But what you can see is once they were established, there is quite a bit of biomass in the soil surface. You can see these are starting to produce their flowers, and a little bit further on, those early seed pods. And the picture on the right can show you that they're pretty viney. So at a certain point, in some cases where the better germination came out, they were able to completely cover the soil surface. So in like the area you can see there, it's impossible almost to see those beds that were lined up. Uh, Lima bean harvest was just a couple weeks ago, and averaging nearly 3,000 pounds per acre. This was just a single harvest. And again, like I said, there's a lot of making sure that you have a place where these products can go. But the value of these, at least what a lot of these organic growers are able to sell for, fresh organic lima beans is a similar price per pound as those fava beans. So anywhere from $5 to $7 a pound. And if you're willing to take the time to individually harvest those pods, so open up the pods and just the fresh beans, if it's a restaurant who is willing to uh, get rid of that labor cost, some of the growers talk about being able to sell that for almost twice the amount. So again, direct selling, you can have a really substantial amount of money, but again, it's maybe not going to be acres and acres of these beans that are grown across California, but in these small diversified operations that after maybe a fraction of an acre where carrots are grown in the winter, after those carrots are removed, lima beans could be a good candidate to give that soil a rest, incorporate some plant diversity. If these, like all of these cover crops that I've been talking about being legumes, if they're able to uh, add a little bit of fertilization to that soil, your next vegetable crop can be a little bit more successful, or whatever amount of supplemental fertilization you're putting on, especially in organic systems where there's not a lot of uh, option, maybe no options that a grower would call cheap. sources of organic fertilizer. And so it's really any amount of additional fertilization you can get is a big win. And the rotation continues. These lima beans were terminated on October 15th, just a week ago. And we're once we again the field that you can see there, um, the same amount of treatments that some are rototilled, some were crimped, that you can see those greener areas, and some of those will be tarped. They were tarped just the other day. And we'll try a broccolini, so a broccoli that has really small, tender stalks and heads that are harvested as the next round of vegetables. So we're going to hopefully be able to have a talk like this that takes what I've talked about, but extends it even further and has even more amount of research that we're talking about. And there's, in the interest of time and not wanting to totally keep everyone here all day, there's a lot of really interesting aspects that we're looking at in the soil. The picture that I'm showing you there is a sensor that reads instantly can read in the first couple inches of soil the temperature of the soil and the moisture content. So that's really important, as you can imagine, excuse me, where you have cover crops or where you don't have cover crops or you've been disturbing excuse me, not disturbing the soil. What does that affect in the temperature of the soil? So that's going to affect how the microbes are behaving and more importantly, the moisture content of the soil. If you're lucky enough to get precipitation, how much of that rainfall is going to be taken in from the soil versus being pooling at the soil surface and evaporated or lost via runoff. And we're also taking soil samples. We took samples from the soil that are analyzed before the first round of vegetables, as well as samples that were done at the end of the first vegetable cycle before the peas were seeded, and we can compare those soil to see how the amount of microbial carbon, how much the different nutrients, nitrogen, potassium, phosphorus, all of those things, how they're changing throughout time in these different treatments. And uh, we're going to continue those treatments at the end of the experiment. So, if you've ever done routine sampling of your soil, you might know things like organic material, organic matter in the soil, or any of these nutrients might take quite a while to build up. So it might be that some of these trends that we would really be interested to see might take 2+ years to tease out. But some of the initial findings, just looking at the data that we have so far, that amounts of soil carbon for a lot of these treatments are increasing. The amount of microbial activity is increasing, but we're not seeing a ton of differences, at least so far, teasing out amongst these treatments. But that's something, as I said, hopefully, as we continue to, in some of these areas, keep them cover crop free compared to routinely incorporating cover crops into our rotation, we might be able to see some differences. And it's not just doing these research experiments, but a lot of what our goal for this project and as the California Organic Center as a whole is sharing the results and sharing the findings through field days at different conferences or events, articles or updates in the newsletter that Rodale puts out, and talks just like this one that aren't as exciting as a getting out to go in the field and check stuff out, see it in person, but it's still a really interesting way that the results can be shared. And if folks are interested in learning more than either the research team or the consulting team from Rodale, who in a lot of cases, if there's uh, a grower who may or may not be listening, is interested in converting from conventional to organic and that transition process, or finding ways to integrate cover crops and finding direct market sources for their products. It's those consulting teams that have the connections, the expertise, or at the very least, the ability to reach out to our research team. And I want to talk about a little bit. This project is part of the California Farm Demonstration Network, which is a group that's major goal is increasing the adoption of conservation agriculture and climate smart practices in the state of California. And so there is a multitude of different research groups or extension groups who have this overarching goal of reaching out to different clientele, reaching out to different grower communities throughout the state of California and making these either directly providing resources, providing expertise, increasing education or awareness of these practices overall. And these are some of the major goals that over the last couple of years we've been working on having demonstration sites like the one that we have in Ventura County, where growers can, if they're local, can come to see these projects in person and uh, have these places where communities of growers who are either all organic or all growing similar products can have these hubs of information or even hubs where these products can be sold and find these markets or find these places where products can go and be one source where either information is available or at the very least contact information of experts is available. And I wanted to make sure that I gave plenty of time for questions. I want to thank folks for listening, and I want to put this out there. The links is to the California Farm Demonstration Network website that I talked about. But if you're either interested in visiting the California Organic Center in person or want to sign up for the newsletter, that QR code that I attempted to field test it. So my phone was able to send me right to the website that we have where, again, you can, if you're local or if you're taking a California vacation and you want to make the California Organic Center a spot right after Disneyland or maybe before, whichever you choose. Uh, we can arrange a visit, and then at the very end is my contact information there, and I'm happy to follow up with any lingering questions. But yeah, at this point, if there are any questions, I'm happy to facilitate talking about them. But if not, thank you so much to those attending, and hopefully it gave you, at the very least, some new ideas to think about. Yeah, the one of the questions and is the question of the scalability of these tarping system, and that's an excellent question. That as I showed, these were relatively small pieces where we were covering with the tarp, and in some other projects where we've had that it's about uh, these are fractions of an acre, less than 2 or 3% of an acre that we're covering with these silage tarps. And as as you can imagine, it requires a couple people to lay it out, especially if it's a windy day and it's blowing away from you, and you have to weigh it down with sandbags. So there is these questions of labor. So there probably would reach a limit to how large these can scale up. But what I think a lot of these practices are tools for these really small, diversified growers who might not have their vegetables or their pieces of land at the same growth stage throughout the year. Because they're trying to continuously have vegetable products or things that they're selling direct to consumer at all points of the year. It would only be small parts of their field. So if for during the month of October, it might be a relatively small chunk where they can lay out the tarp, and after they harvest their last bit of peppers, then they or if they had a summer cover crop, can terminate it, can give that soil a period of rest while they're working on others. And as I said before, it can facilitate a little bit more weed germination and help you for your next amount of vegetables start on the next step. But for these farms that have the availability of higher amounts of labor or more resources they're willing to dedicate, you can buy bigger areas of these tarps and lay them out. There's no shortage of labor-intensive practices in a lot of fruit and vegetable systems in California, whether it be laying out large sprinkler pipe irrigation systems and some cropping systems such as strawberries. There's a lot of bed work and even covering the soil for fumigation in these conventional farming systems. So there's a lot of labor intensive practices. And if you can do some of these practices that are instead of relying on chemical inputs, but instead maybe allowing you to not disturb the soil as much, allowing you to dedicate less labor cost towards weeding practices, that can be something that makes a lot of sense in the long run for a grower. But every farm is going to be a little bit different, what they're growing, what their labor or financial constraints are. And so a good thing also to say on that I would really I it would be hard to take in any research experiment we do or that you ever see to just copy and paste it to your own farming system. Every farm's different. You as the grower know your soil, know the unique challenges to your climate, to your region, and it's going to be taking all these pieces into account when you're creating your management program. So yeah, I think like I said, if there are questions that come up late, please don't hesitate to reach out to me down the road. I appreciate you taking the time.